Here's another overall vector. This overall vector again has a magnitude of 5, and its direction is 53 degrees below the horizontal and pointing to the right. So of course, we never use a sign for an overall vector, so there's no point indicating a sign on this number 5 over here. This is a magnitude, and since there's no such thing as a signed overall vector, I don't need a dot to indicate that. Well, try to pause the video and draw the right triangle that indicates the components here. Please draw the right triangle that indicates the components. You don't need to calculate anything, just draw the right triangle. We need to draw a right triangle that uses the overall vector as the hypotenuse, and the legs should be parallel to our axes. Here's a right triangle that's using the hypotenuse as the overall vector, and this leg is parallel to the x-axis, and this leg is parallel to the y-axis. By the way, I want to mention there is another right triangle you could have drawn here. There's another right triangle you could have drawn. I've just recopied the original vector over again. This is the same vector as before, just recopied. There's another right triangle you could have drawn. You could have drawn this right triangle. This is also a right triangle that uses the overall vector as the hypotenuse, and the legs are parallel to the axes. But this is not really a very good right triangle to draw. Why is this not a good triangle? Because it doesn't include the angle that we were given. So that's something else that I didn't mention. When you're drawing your triangle, you want to use the overall vector as the hypotenuse. You want the legs to be parallel to the axes. And if you can, you want it to include the angle that you were given. So you can see that if I draw the right triangle down here, it leaves out this 53-degree angle. So anytime you draw a right triangle, you can either draw the right triangle above the vector or below the vector. We can either draw the right triangle above the overall vector or below the overall vector. Where should we put it? Well, we should try to put it in such a place that it will include the angle that we were given. In this case, the way to include the angle is to draw the right triangle above the vector. Now, it wouldn't be a disaster if you drew this right triangle, because you can just use a little bit of geometry to figure out how big this angle is and how big this angle is. So it would be perfectly fine to actually draw this triangle, and then you could just use geometry to find these two angles. That should be pretty easy for us. But that's not the way it's conventionally and usually done in physics. Usually in physics, people try to draw right triangles that include the original angle that you were given. They usually are not going to draw a right triangle where you're going to have to transfer the angle in. So even though you could use this right triangle, we're going to try to get into the habit of not doing it this way, because this is not the way you'll see your instructor or your textbook do it. All right, so even though this is not technically wrong, it's not the conventional approach. So we're not going to use this because it's not conventional. Instead, we're always going to draw the right triangle, if we can, to include the angle that we were given. All right, as usual, I'm not asking you to calculate the lengths of the sides. I'm just telling you the lengths of the sides. In just a few minutes, we're going to start learning how to calculate the lengths, but here I'm just telling you the lengths. Now, notice that I haven't put any signs in front of these numbers, but that's perfectly okay because these are magnitudes. Magnitudes don't need signs because they're always positive. How do I know they're magnitudes? Because I used the dots. And I didn't need a sign over here because this is the overall vector. An overall vector never has a sign. Okay. So now, of course, what we'd like to do is to actually write down the signed components. Now we should actually write down the signed components. So please pause the video and try to write down the signed components. Did you notice that before we can write down the signed components, we have to put arrows on the legs of the triangle? Remember that the triangle is not finished unless there's arrows on the legs. Well, our overall vector here was pointing down and to the right. the original overall vector was pointing down and to the right. Therefore, the components should be pointing down and to the right. Since the overall vector was pointing down and to the right, we should have one component pointing down and one component pointing to the right. Now we can figure out the signs. The positive x direction is to the right, and the x component is also to the right. So the x component was positive 3. Positive is to the right, and the x component is pointing to the right, so that's a positive component. How about the y component? The positive y direction is up, but the y component here was pointing down in the negative direction, so the y component was negative 4. Positive is up, but the component is pointing down in the negative direction. All right, now remember that if you wrote v sub x equals 3, that's wrong. If you're writing down a signed component, you have to include the sign, even if it's positive. We didn't need the sign here because this was just a magnitude. Magnitudes are always positive. But the overall component could be either positive or negative. So if it's positive, you have to indicate the sign. Again, I know that this is probably not what your instructor is doing, but what's good for your instructor is not good for a beginning student that's having difficulty with the material. So I'm strongly encouraging you to adopt this notation when you're working through these problems. Again, one of the main purposes of this part of the video is to get you comfortable with what I mean by the dot, because I'm going to be using the dot in the whole rest of these videos. And if you watch any of the other videos I've made on physics, I'm going to use the dot there. So unless you want to give up on me and give up on these videos, you better learn what the dot means. Even though that's not a standard symbol, my experience has shown me that beginning students really need a separate symbol to distinguish between when a variable has to have a sign and when the variable is not going to have the sign. So I'm not saying this is easy, but this is really necessary in order for us to get the problems right with confidence.